Hello everyone, and welcome back to the math. So in this video, we are going to learn how to solve a more complex equations that actually hides a quadratic equation. If you haven't watched the previous videos regarding quadratics, I will put a link on the top right of this video. In this video, like I said before, we will learn how to solve complicated equations that actually involves a quadratic equation. The first step is to always simplify the equation such that it looks like a quadratic. Now, you might not be able to imagine what I'm talking about right now, but we will see in the examples. At first, this will look complicated, but I'll try to provide as many examples as I can so that you can get used to it. This is the first example that I want to show you guys. This doesn't actually look like a quadratic equation, right? But remember that we can simplify the equation such that it looks like a quadratic equation. So how can we do that? First, we can assume that a is equal to square root of x. Because of this, square root of x becomes a, x becomes a squared. So we can just try to substitute and we have a very nice quadratic equation. After this, we can try to find the roots with whatever methods that we have learned before. And this becomes a minus 2 times a minus 3 equals to 0, and we get a equals to 2 or a equals to 3. But remember, we are not done yet. We need to find the x. How can we find the x? We can use our previous assumption because we know that a is equal to square root of x. So square root of x is equal to 2 or square root of x is equal to 3. Therefore, we can get an answer of 4 and 9. And remember, there is no plus minus sign when we are squaring. The plus minus sign only applies if we are taking the square root. So it's going to be very different technique, okay? So in the next example, as you can see, this doesn't look like a quadratic equation at all, but it's very similar, right? So we need to remember that we can simplify the equation such that it looks like a quadratic equation. Again, we need to assume something. We assume that a is equal to x squared, so x squared becomes a, and then x to the power of 4 becomes a squared. We can try to substitute this and we get a very nice quadratic equation. Again, we can try to find the roots. I'll try to do it by factorization and we have a equals to 1 or 2. Again, we need to find the x. We're not done yet. So we can try to use the assumption that we have before and we have x squared equals to 1 or x squared equals to 2. Since we are taking the square root out of this, now we have plus and a minus sign. So x can be plus minus 1 or plus minus square root of 2. And as you can see, there are a total of 4 solutions in this problem. On to the next example. As you can see, it's going to be very similar to the one before. We can try to assume that a is equal to x cubed. So if a is equal to x cubed, that means x cubed becomes a, x to the power of 6 becomes a squared. We can try to substitute this when we get a very nice quadratic equation. We can try to find the roots. We have that a is equal to negative 1 or a equals to 8. Again, we shall try to find the x. So we have x cubed equals to negative 1 or x cubed equals to 8. And we have that x should be minus 1 or 2. On to the next example. This doesn't seem like the previous examples, right? But the method will be the same. So a should be equal to 1 over x squared. So 1 over x squared becomes a, and then 1 over x to the power of 4 becomes a squared. We can try to substitute this and we get a very nice quadratic equation. We can try to factorize this to find the a, and then remember we need to find the x. So for the first answer, 1 over x squared is equal to 4. So we need to take the square root of this and we have x is equal to plus or minus 1/2. The second answer, we know that 1 over x squared is equal to 9. So we take the square root of this, we get x is equal to plus or minus 1 over 3. Again, there will be 4 answers. Now in this example, this looks very similar to the one before, so we shall try to do the same. So a should be equal to x to the power of 5. So that means 1 over x to the power of 5 becomes a, and then 1 over x to the power of 10 becomes a squared. Again, we can try to substitute this. We get a quadratic equation. We can try to factorize this, and we have the a values. Again, we can try to find the x. So the first one is going to be 1 over x to the power of 5 equals to 1, which means this results in a 1. And then the next one, 1 over x to the power of 5 equals to 32, and this results in x equals to 1/2. As you can see, this one is a bit different than the previous examples that we saw before, because in this case, we have to find the real solutions. Remember that solutions can be real or imaginary, and we have to focus only on the real one, okay? So again, we can try to assume that a is equal to x squared, and that means x squared becomes a, or x to the power of 4 becomes a squared. After this, you can try to substitute it and you get a nice quadratic equation. You can try to find the roots, find the a, and after this, you can try to find the x. So in this case, first, let's see that x squared is equal to -4. We know that there is no x value such that when you square it, it becomes a -4, right? So for the first one, we have no real solutions. But how about for the next one? For the next one, we can try to take the square root of it, and we get x is equal to plus or minus square root of 3. And remember, this question only asks us for the real solution, so we should try to focus on that one. We are now going to see a different type of equation, but again, the method to solve it is going to be the same. As you can see, we have an exponential in the equation now, but that's okay. So we can try to assume that a is equal to 2 to the power of x. 2 to the power of x becomes a, and 4 to the power of x becomes a squared. Remember that 4 to the power of x is equal to 2 to the power of x squared. So this is what we learned in the exponential material. After this, we can try to substitute it. We get a good quadratic equation, and then we can try to factorize this. We get that a is equal to 4, or a equals to 8. So 2 to the power of x is equal to 4, which means x should be 2. And then 2 to the power of x equals to 8, which means x should be 3. Okay, so now I will try to give you something similar as well. So this one will also involve an exponential in the equation. Again, we can try to assume that a is equal to 3 to the power of x. And 3 to the power of x becomes a, 9 to the power of x becomes a squared. Remember the exponential materials. After this, we can try to substitute it. A squared minus 10a plus 9 equals to 0. We can try to factorize this. We got the a. So a can be 9 or 1. And we can try to input it in the initial assumption. So 3 to the power of x equals to 9, or 3 to the power of x equals to 1. So x should be equal to 2, or x should be equal to 0. Okay, so this is the last example that I can give you in this video. And as you can see, the exponent is a bit different because we have a negative exponent, but that's okay. The method is going to be the same. So you assume that a is equal to 2 to the power of minus x, and 2 to the power of minus x becomes a, 4 to the power of minus x becomes a squared. Remember the exponential rule. After this, you can try to substitute it into the equation. You get a very nice quadratic equation. You can try to factorize this, and you get that a is equal to 1 over 2, or a is equal to 1 over 4. And again, we need to find the x. So we can try to use the assumption that we have before. So it's going to be 2 to the power of minus x equals to 1 over 2, which means x should be equal to 1. And then 2 to the power of negative x equals to 1 over 4, so x should be 2. So based on the examples that we saw earlier, we can try to wrap things up and then we can see the pattern. So for the first one, we can try to assume that d is equal to x to the power of n, and then we can substitute into the equation. For the middle one, it's also the same, but in this case, d equals to 1 over x to the power of n. And then for the third one, the exponential form, we can assume d is equal to m to the power of n and substitute into the equation. So we need to remember the exponential rule that x to the power of 2n is equal to x to the power of n squared, which means it can be d squared, okay? Because we know that in the assumption, d is equal to x to the power of n. And then always ignore the imaginary solutions if there are any. Okay, so these are the exercise that I've prepared for you guys. I hope you can try to do these exercise and get used to the method that we learned earlier. I'll try to put the solutions in the description box. Okay, so that's it for this video. In this video, we learn how to solve a more complex equation that involves a hidden quadratic equation. So we need to simplify it, we need to make some assumptions, and then we can find the x. What do you think about this video? Please leave a comment and don't forget to leave a like and don't forget to subscribe. I'll see you on the next video. Thank you.